Show of hands for product managers here. Anyone? Hadoop, cloud? Oh, one. Awesome. Two. Okay. So it's somewhat geared towards platform PMs. Nonetheless, I think it will be useful for pretty much anyone, be it a developer or a business decision maker. It really hones into this idea that if you have a large on-premise infrastructure, you can practically run it as a business, although you're not offering retail services in any sense. So that's pretty much what the talk is about. And we'll actually draw insights from when we conducted this exercise at Yahoo. So let's talk about what the problems were, right? There were 3 questions being asked. And the first question was primarily around every time we go to the CFO and say, oh, a few $1 million more in hardware, he will say, oh, okay. Why is it continue to going? Why does it continue to go up? The second question was really around there were lots of new people coming into Yahoo or has come into Yahoo in the last 2 years, and they're very familiar with public cloud operations, right? So they understand the nitty-gritties of those operations, and they ask a question: okay, how viable, how good is our business when you're running such a large-scale infrastructure on premise? And then the third question is really around utilization and ROI. Am I spending my money wisely? Am I getting what I'm supposed to get out of this platform? So essentially what needed to happen to answer these questions was that for the first one, you had to institute what you call as an internal platform P&L so that you can run this platform as a business. On the public cloud front, we had to provide transparency in our costs. And benchmark those costs properly so that we can actually compare apples to apples. And then finally, for the last piece, it was really about providing provisions that could allow you to meter your usage for the platform. Right? So, and these questions become quite relevant if you think about our scale at which we run Hadoop. We run anywhere between 35 to 40,000 servers every month. And sometimes it peaks up. It depends. It's a moving number. In terms of storage, it's over 400 petabytes of raw storage. Practically, it has become what we call as the lowest common platform at Yahoo to do pretty much anything. We've been doing this a long time, and those questions were quite justified. So what we're going to do actually in this talk is tackle those questions, tackle those 3 questions in a very structured fashion, right? We'll talk about how do you think about your options when you actually are setting up a Hadoop-based platform or a Hadoop-based service for your company. Then we're going to look into the total cost models. How do you actually think about your total cost? And then we'll try and gather deeper insights into how this platform gets used and how do you measure those. We'll also talk about P&L metering and billing provisions. So in case you have a platform like that, how do you actually measure the usage and then actually bill people? And even if you're not billing practically, how do you show those charges back to the users? And then we'll also take an approach to benchmarking costs because that's important. And then finally, talk about how you can actually improve utilization and return on investment on this platform, right? So kind of a relevant topic, very relevant topic for us given the scale of our operations. So if you think of Yahoo and the deployment models at Yahoo, there are really 2 predominant deployment models that are on-premise. And then there are some scattered use of public cloud. So the first one is what we call as dedicated clusters or private clusters. Now, these are usually put in by people who are playing with technology, new technology, technology that hasn't been platformized yet. The middle one is what we call as the grid, is the centerpiece for Yahoo. This is the hosted multi-tenant platform practically for all data at Yahoo. So this is the single source of truth for all data at Yahoo, and that was the idea behind bringing it into a common platform. It allows us to bring applications very, very quickly to market because most people do not have to worry about the intricacies of the platform and how you run Hadoop as a service. And then it has all the properties of cloud, which is the operational efficiency, economies of scale, and things like that, right? And then some of the acquisitions we have done in the past actually have had their infrastructure built on top of public cloud. So some of them still live. Some of them are in the process of migrating over. Some people actually do experiments on public cloud. So there is scattered use of that, but the predominant form of Hadoop as a service at Yahoo is the on-premise model. Okay? So if you're starting fresh, how do you think about it? There is really no hard and fast, I would say, criteria. It is what works for you. But if you were to really think in a structured fashion about which option do I choose, you have to first consider cost, because that's quite important, practically when you're making business decisions of this scale, the scale that I talked about, and depends on what your future plans are, current plans are. But cost is important, because in on-premise model, you're going to incur a fixed cost, and it's often a high cost. It does not change by whether you use it or not. Whereas on the cloud side, it varies by your usage. It's convenient. And then data is another important factor, because data movement is a huge pain. So if your data gets generated in a place that offers Hadoop as a service, probably is the best place for you to run Hadoop services. Whereas in our case, we aggregate data from hundreds of thousands of, not hundreds of thousands, but tens of thousands of servers all across the globe into some central place. So for us, it actually makes sense to run these services over there in those data centers. SLA is also quite important. And when I say SLA for customers, it's not just about availability or uptime. It's about a whole bunch of other things around latency, around throughput, around different types of provisions in terms of job completion times and other things. So if you're thinking of something like that in a public cloud, it's really up to you to dedicate enough resources for those SLAs to be met. So you need to be cognizant of that. Technology stack and adjacent technology stacks. So for example, not just asynchronous processing of data, but also the synchronous serving, which is the cloud serving side. So in our case, it's ad serving, it's content serving, along with data serving. And we have made investments in those areas as well. So it's actually a whole lot easier for us to put the two together. So you need to understand the control over deployed technology that you might need to exercise. That becomes a consideration as well. Security is a big deal, actually, and it's a bigger deal for on-premise, on the contrary of what people may think, because what happens typically in cloud is that your data isn't really shared by anyone else. It's your data, it's stored in the cloud, and you use that data and run analytics on top of that. Whereas in our case, the idea was to bring all data in the company in one place, and everybody is sharing that data. Everybody's looking at that data. And some of that data is quite sensitive. Which actually then forces you to think about pluggable security models, access controls, and lots of other things that brings complexity in your software development process. And then finally, multi-tenancy, because if you want to run on-premise infrastructure optimally, you actually want to have a multi-tenant platform. You want all tenants, all users of that platform to be at a single place. So again, there is no I would say right or wrong answer. It depends on what works for you, what doesn't. But these are the criteria you may think about. A single criteria may sway you in one direction, and that's okay. This talk is really going to focus about cost and SLA, which is what you're actually going to measure quantitatively. And then the idea is that if you have an infrastructure, if you've decided to go with an on-premise infrastructure, how do you actually manage that as a business, right? So let's get into that. So TCO is the first step, understanding your total cost of ownership. It's not just about the cost of servers. This would be the hardest part because it requires gathering data from multiple sources. In our case, it was quite complicated. So what you start off doing is by actually accounting for your hardware cost first. And again, you have to understand how much of your hardware is already depreciated, how much is in which schedule of depreciation, and how much of it is new, right? And it's just not server hardware, it's all kinds of other things. The second one is R&D headcount. If you're actually platformizing Hadoop, you need platform headcount to work on Hadoop, and that can be significant. The active use or operations cost, data center cost. Again, really, power is the main thing here, but you need to account for that, and that's the recurring cost. Network hardware is also important and can be significant. So you need to account for all the network hardware. You need to account for one-time costs, particularly as it goes into acquisition of hardware and installs. You need to account for operations because, again, as your infrastructure scales up, you need significant amount of headcount to manage the operations of the infrastructure. In our case, it's actually pretty world-class if you think about the percentage breakdowns between the operations and the scale of our infrastructure. And then finally, network bandwidth. This is really the data coming into the data centers and going out of the data centers. That can be significant too. So as you've gathered this data from various data sources, you could actually come to a monthly breakdown of each of these costs, and that's going to give you the total cost. Now, the numbers in these slides are completely fictitious. Right? These are not our numbers, so there's no point tweeting about any of that. So let's say when you accounted for all of this, your total cost of ownership for running this platform as a service is $2.1 million monthly. Right? Just say, for example, and we'll work with that number through this talk. So once you have determined your total monthly cost of running this as a service, you need to now get down to something which is a measurable unit of resource or usage. So you will start with deriving unit cost for resources that are in play here. And in Hadoop, really the two primary resources that are in play are storage and compute. So let's start with compute. Compute is essentially slots or containers. We'll get to what slots and containers are in a second. That you actually need to process data, right? And you don't always process data. You don't always access HDFS. Sometimes it's just compute. So the units there are dollar per slot hour, because slot is the unit for compute or container. So again, we'll get to what these are in a second. And then you also need to understand your total capacity. So total number of slots in your infrastructure, total number of compute units in your infrastructure, be it slots or GBs of memory. And then you just divide those two numbers. You know your monthly cost. You just don't know your monthly compute cost yet or monthly storage cost yet. And we'll come to that in a second. Similarly, you understand your unit cost for storage. So it's dollar per GB of data stored, and you can work with raw storage or you can work with usable storage. It's totally the same thing. It's just that you have to do the same math everywhere. And then bandwidth is something that I described to you. It's not similar. It's computed similarly. It kind of sits outside of Hadoop, but it's an expense that's required to bring data in and move data out. Right, so that typically is measured as dollar per GB of data moved in and out. And then finally, namespace. Namespace is quite critical. This is really the number of files and directories that a particular cluster can support. It's a commodity that we don't charge for because we've already accounted for name nodes hardware, but it's something that we manage very, very carefully. It's a resource that we manage very carefully, not necessarily charge for it. So we've set quotas around this. Okay, so just call it from a cost perspective, not applicable. So we understand the total cost. We understand what the unit costs might be to run Hadoop as a business. Now let's work through an example of what that might translate to. So let's say in my case, my monthly TCO was $2.1 million. 0.1 was for bandwidth, so I take that out. What that leaves me is with $2 million for storage and compute. In our case, the servers are, so we buy both compute and storage together in a uniform server. So the storage for us are just JBods here. So what we do is actually we split it 50-50. It depends on your situation. If you're using storage separately or buying storage separately, you know what your costs are for storage, you know what your costs are for compute. In our case, it's 50-50. Let's say so, and then let's say hypothetically, my total compute capacity is 185,000 slot. Now these are fixed numbers, but you need a notion of time for how long it was used. So what you do is you give it a notion of hour. So in my case, I'm multiplying it by 24 for a day, and then by 30 for the month, because I want to arrive to monthly costs. So I get a notion of slot hours here, some million of slot hours. And if it's GB memory-based, it's about the same thing. It's just GB hour instead of slot hour. I will explain what that is and why that difference exists. So you know your monthly compute cost, you know your monthly compute capacity, you just divide them, you get to a unit cost. In this hypothetical example, it's $0.004, okay, or 0.4 cents. Actually 0.7 for slots, and then for memory it's higher, lesser. And it actually makes sense because on an average, each slot in our case is about 1.5 GB. It depends on what your server configuration is and how much memory you typically or traditionally allocate to processes. And then storage is, again, quite straightforward. You know your monthly storage cost. You know the raw HDFS. In my case, I'm actually using usable storage. So Hadoop has a 3x replication factor by default. There is some storage space that goes away in terms of overhead, like temp space, OS itself, and other things. So I'm taking 20% of the storage out for that. And you arrive to your total storage capacity, usable storage capacity. You divide that by the dollars you have had, you get to a unit storage cost. Okay? Bandwidth, as I said, is different. We usually pay for the interregional links between data centers, and you get a monthly bill for that. And you know exactly the amount of data you've transferred in and out of the clusters that you actually put it on these interregional links. You get to the bandwidth cost as well, or the unit cost of bandwidth, which is $ per GB. Right, so quite straightforward in terms of understanding the total cost, working through unit cost, and then arriving or working through an example in terms of understanding your total compute and storage capacities. So we talked about slots, we talked about containers. They're essentially both elements of memory. In Hadoop 1.0 or Hadoop 20 branch, essentially what happens is that you carve out your server into a number of slots for mappers and a number of slots for reducers. Okay? So you have sort of a fixed number of mappers and reducers for that server once you configure it that way. And then each map task may take one or more slots to run based on how much memory it needs, and similarly the reducers. The reducers in general are slightly larger than the mappers. What has happened in Hadoop 2.0 or Hadoop 23, the branch we run, is that the node, again, the memory of the node is carved into fixed sized allocations that is defined by a parameter, which is the minimum allocation size, let's say 512 meg in our case. And then Yarn, which is the scheduler or resource manager for the next-gen Hadoop, what it does is that it actually allocates containers for your map and reduce tasks to run based on how much memory it may need. So a little more flexibility compared to the previous version, but they're both elements of memory. Okay? And that's how compute resources actually work in Hadoop. They're not really CPU related, they're memory related. Okay? This is just an example of memory from one of our clusters that's running Yarn in terms of memory it has used, memory that's available. Right? But you can't really do this because now that you have understood your total cost, unit cost, what you now need to do is actually start to measure people as to how much they're using so that you can effectively bill them, so to say, if you have to, at the cost basis, right? So you have to measure their usage. Again, usage is measured in a much simpler fashion. What you do is actually for every job, you calculate how many mappers and how many reducers the job ran. You take the number of slots that every mapper occupied, the time that mapper ran for. Similarly, the number of slots a reducer occupied, for all the reducers, the time the reducers ran for, sum all that up, that's your usage for compute. Okay? and then you know your unit cost. You multiply that by your unit cost, you get the cost for that job. And now that job was run by a person, a project that belonged to a business unit. What you can do is then roll that up job by job for all the jobs for a user, for a business unit, or for a project. So what you get to here is the monthly compute cost per project, per business unit, per user, whatever the case may be, and how you may want to roll it up based on your business situation. Storage was computed slightly differently because you don't want to double charge for the usage of same storage space. So storage in Hadoop is typically organized in HDFS directories and NS files in those directories. In our case, most of the data, common data, lives in something called a /data directory. The project space, so for the storage space for the applications, so the projects live in /project. /project belongs to a project, so you can directly charge how much data, how much space have you allocated for that project. /user belongs to a particular user. You can build that to a user who belongs to a business unit or works in a particular project. /data is tricky because that's a common directory for data that is shared by multiple people because it's a multi-tenant environment. So what you do over there is actually you weigh the reads for that data. So if I am the only one in that month reading that data and nobody else is using that data, I'm going to get billed for all that data because I'm the only one using that data. If other people are also reading that data or using that data for their projects, then you bill them as well based on their rates. Okay? And then bandwidth is, again, tricky because we don't measure it per job. It's really per cluster. But there aren't that many people who are actually, during their processing phase, bringing in data and moving data out. And the ones that are there, we know about them. So we bill for the bandwidth to those users, those applications, or those users. Right, so this is how you determine usage. Well, so all of these numbers here are coming from, let's say, job tracker logs. It's easier said than done because the volume is pretty high. So if you take our example, we run 17 million jobs every month. You can't do this math by yourself. So you need a system that will allow you to track usage. In our case, that system's called Starling. And Starling's nothing but an analytics warehouse, a system, sort of log warehouse. So all the logs that job trackers generate, task trackers generate, every system log, it's captured at one place. So what we do is actually run a Uzi workflow and distribute all the logs from every cluster into one central place. Okay, we process that and put it into HCatalog. HCatalog, if you're not using it, you should become familiar with it. It's a pretty useful product. And so in this case, all the raw logs and the processed logs are kept in HDFS, but the metadata that belongs to those data, it's kept in HCatalog. So HCatalog gives us the tabular abstraction for that. And then you can query this data. So you can query this data via query server. In our case, let's say it's Hive Server 2, or through using Hive, or through Hive CLI directly. And if you have other systems, like we have customer portals or other custom, I would say, dashboards for reporting on usage, you could integrate all of that into the same system. Right? So if you have something like that, then what happens is that you can manage all the information about your Hadoop platform in one place. And so in our example, let's say 1 terabytes of system logs are moved from these clusters every day. And then once it gets processed, we store those text files as RC file and use Hive to run analytics on those to understand truly who's using what, who's doing what. It gives us a lot of insight into how the platform is used, particularly when you grow to a size where you lose control. This is something which is really, really useful to understand what's going on. So it gives you all kinds of intelligence you may need through historical analysis. And then finally, it can also help us plan capital based on the trends we're seeing for the future. So let's say, my CFO says, okay, I need to understand your 2014 plan. How many $1 million of gear are you going to buy, given that it's a large cost element in our CapEx budget? I need to be able to answer that question. to the best of my knowledge, and something like this helps. And it has many uses. Metering and billing is just one type of use, which is I'm trying to highlight here. But you could use such a thing for many different things. Okay, so you know your usage, you know your unit costs, you know your total costs. You can actually now generate a bill pretty easily, either at the business unit level or the project level. And the elements of the resources that you're going to bill people for are compute, storage, and bandwidth. It becomes quite straightforward at that time to generate monthly bills like that for everybody. You understand your bills at the platform level. You understand your bills at these individual levels, right? You could also construct a P&L at this point in time. Nothing stops you because you know your CapEx elements, you know your OpEx elements. You can truly understand the contribution margin in terms of what it costs as a percentage of revenue, and basically your platform becomes a business, right? So at this point, you truly understand what percentage of your cost or what percentage of company revenues is your cost, and whether that cost is justified or not based on the revenue you're generating for the business. You can understand the trends and how your cost elements are changing. Okay, so let's talk about, it's good to know your cost, but it's also good to know whether you're cost competitive. And how do you do that? So, there are two approaches here. A, you can take all your workloads and run it in some other environment for the same amount of time with the same SLA, and then toll the cost as you incurred there, and look at your own cost and say, okay, my cost is lower or my cost is higher. That was an impractical exercise for me. So I went the theoretical route, where what I did was I truly knew what the used resources were in my infrastructure and what left unused when I did that monthly calculation for jobs, for other things, because I knew my total cost irrespective of the usage. It's an on-premise infrastructure, right? Your costs are fixed. And then, so for MapReduce in HDFS, and I'm ignoring bandwidth here, assuming you're going to have the same bandwidth cost no matter where you move data in and out on interregional links. Let's say we're competitive from a bandwidth standpoint. So what it allows you to get to is the split between total cost of used and unused resource of your total cost. And then what you do is you calculate the quantity equivalent that you may need if you were to take all your workloads on a public cloud infrastructure. So what I've done is actually I've only transferred the used portion of my infrastructure over to a public cloud infrastructure, and I have tried to get the same type of configs, same amount of memory, same amount of, or similar types of instances. Storage is storage, so it really doesn't matter. In this case, the storage is separate, so I've ensured that I've allocated enough storage space on a public cloud infrastructure. I've ensured that I have gathered enough instances, or instance per hour is how they bill it typically, in GB per hour, and I've known that, right, for my own infrastructure. So at this point in time, I gathered equivalent quantities from a public cloud. I sort of know the public pricing, and what I do is I run the costs again for the used portion of my business. And it allows me to really understand how cost competitive my operations are compared to, let's say, the public pricing for a cloud provider. Now, this is not a true comparison in the sense that it's kind of a gross generalization, but this is the best you could do to understand your competitiveness. But what's important here is to highlight is that it's not just about comparing the two costs on two different settings. What's important is that you have to go further. Go further in terms of understanding your expected utilization or target utilization or future plans. Because what starts to happen is that the cost curves for a public cloud infrastructure and an on-premise infrastructure follow very different sort of patterns. As you grow, or as your utilization grows, your usage of the platform grows, at some point in time, what you will start to observe is that the spending that you have on public cloud infrastructure will actually start to get very, very expensive compared to your own operations. Whether you go with on-demand pricing or whether you go with a term-based pricing, it doesn't really matter. It's about scale and it's about utilization. So that's the idea here. Do not stop at just benchmarking costs or comparing costs. You have to think further in terms of conducting a sensitivity analysis based on your business. Okay? And then the focus of the effort should be on improving ROI, which is what the question asked was. And as you can see, this blue line here sort of shows the linear growth in the use of the platform. So more and more applications are running or using Hadoop. And what that starts to do is that the cost, your monthly cost amortized over those applications, start to drop. Okay? And what that can do is actually it can help the top line. It can help the profits of your business units. So, it's simple, right? Profit is revenue minus cost. You're bringing the cost down for a particular business unit because more people are using the platform. Even if his revenue stays the same, you're actually improving his profit. And that's exactly what platform guys do. Okay? So how do you achieve? Okay, before we get into further discussion about how do you actually improve these factors, let's take a moment to understand why these things happen. Why is utilization the way it is? Why can't it be improved further? Because there are demands on the platform that actually forces you to behave a certain way. One of the first demands is about the schedule in software rollout, right? So what we do is actually we follow a process where we start from a sandbox environment, get into research environment, and finally into production environment. That allows us to stay stable. Because guess what? If something goes wrong in your rollout on a production system, that's a revenue-bearing system, you can't roll Hadoop back. Oh, go back to the old. Something went wrong. You can't do that today. So it follows a phased rollout. And that affects utilization because sandbox and research clusters are not utilized the same way as production clusters. The second important factor that impacts or affects utilization is service level agreements. What if data arrives late and the data that was supposed to arrive now has also arrived? You don't really have capacity to process both simultaneously. Because you only provision for enough capacity to process a set of data. What if something happens? What if something goes down? What if somebody pulls the power plug? You need to switch over to a BCP type instance. You need to have enough capacity for BCPs. And then what about processing times? What if I want something that I wanted to finish in 10 minutes, now I want that to finish in 5 minutes? There's nothing that stops that job to finish from 10 minutes into 5 minutes. You just need more hardware. That's the nature of parallel processing. So all of that impacts utilization. Okay? Technology needs. Now, use cases that we have are very varied. The workloads we have are very varied. And people need different types of components in the stack to fulfill their use cases. And each of these technologies have different demands, different configurations that are optimal for them. So solving for I would say, common configuration for all of these different characteristics is quite hard. You will find that difficult. And that impacts utilization. Okay, and finally, multi-tenancy, just by the nature of what it is hard. But multi-tenancy works in favor of improving utilization in general, but it's harder to achieve from a software standpoint, harder to operate as well, by the way. So what we have done is that we have standardized on Yarn. About a year ago, we rolled it out on our production clusters. And the idea is to actually create a cluster, sort of a heroic cluster that can run any workload, and still be optimizing for resources in that cluster in the best possible fashion it can. It's a journey, so we're kind of moving in that direction. We're somewhere, I would say, we've gotten started pretty well. And if I have to show you some proof points of what it has done to us, the purple intersection lines in this slide actually shows the rollout date. The dark blue line is pre-Yarn. The light blue line is post-Yarn. And you can see that we're running more jobs, way more jobs, almost 2 times the number of jobs on the same resource as we were doing before, right? So pretty good in terms of improving or justifying the return on investment, either in software development or CapEx. And those were, by the way, metrics from real clusters. The first one was an advertising cluster. The second one was an audience cluster. So going forward, what are we thinking about doing in this area? High availability is a big deal. We have not rolled that out properly to all our systems. But name node HA, actually HA across the stack is what's really important, because the longer you keep the clusters up, the more utilized they will be. Scalability is another important factor. It does wonders if you actually had a single gigantic cluster, as long as you can ensure that it stays up 100% of the time. Nothing happens to any of the revenue-bearing workloads. So, scalability is a big deal, both vertically on the namespace and horizontally with federation or without federation. So that's something that's going on right now. And there's lots of improvements possible in resource management and YARN layers. Some of this is supporting long-running jobs for queries or low-latency processing. And there are a bunch of other things. As I said, all the scheduling is really around memory. So we want to be able to use CPU as a resource as well. And then when you talk scheduling, there are a bunch of improvements that's possible in terms of managing priorities properly, preempting jobs that are of lower priority in favor of higher priority, and things like that. All of that has a good effect on the business. So thank you for your patience. I know it's the last talk of the day, and I sincerely hope that it was helpful. Questions at this point? For me, nothing. It's none of my concern. I'm a platform guy. I provide service. And let me walk you through an example. So let's say somebody wants to build a targeting application that targets ads for particular users. The revenue uplift by doing targeting is his business. That's his application. All it matters to me is that his application runs on Hadoop, and I want to provide him with the best service in terms of actually running his application in the most cost-effective manner. And if I can do that year over year, even if his revenue stays stable, his profits are going up because I'm actually providing him the services at a much lower price point or cost point. So yeah, no, we platform guys are not responsible for, let's say, revenue, unless my CEO says to me, go ahead and actually open up your platform as a retail model like Amazon. Sure, then I will have a revenue component. It will be good. What else? Anything, Hadoop, cloud, whatever you want to ask, Yahoo. Yeah?
Can you talk more about the challenges of multi-tenancy? There's different levels of hardening that movement.
Very, very, very good question. The general answer is multi-tenancy is hard. Hard to develop, hard to manage, but really good in terms of improving overall cluster utilization. So Hadoop was made multi-tenant somewhere around 2009, 2010. And if you actually refer back to the chart I showed you about the uptick of Hadoop services at Yahoo, I have to go a long way back, but let's see if I can do that. There you go. So as you see, somewhere should be there. Okay, 2009, revenue systems with security, multi-tenancy, and SLAs. That was really one of the breakout years for Hadoop at Yahoo. Because what we were able to do is actually host many customers and meet their SLAs all in the same cluster. Like on that cluster, somebody was an advertising guy versus somebody was somebody else, something was something else. Their workloads, their characteristics, and their demands were quite different. But with multi-tenancy in Hadoop, we were able to accommodate all of that. Now, that requires managing what we call as job queues. I didn't get into that because I don't have the time. That requires managing scheduling in a more sophisticated manner. That requires, I would say, setting limits and how you utilize your cluster in a very intelligent manner. So it has an operational overhead. We're doing the same thing with every component. Last year, we made H-based multi-tenant. So now all our H-based customers actually sit on the same H-based cluster. And by the way, they have very different performance demands. Somebody says, I need 20,000 writes per second. Somebody says, I need 5,000 writes per second. Oh, by the way, the read latency shouldn't be more than 50 milliseconds. My write latency shouldn't be more than 10 milliseconds. So what is happening is that with multi-tenancy, you're able to accommodate these different characteristics, different demands on the cluster, all while operating a single cluster. So it's beautiful in many sense. We're doing this with Storm right now. Hopefully in Q1 next year, we're releasing it internally. Hopefully all that code gets checked in that makes Storm multi-tenant. Now, one of the prime issues with multi-tenancy is security. Because now you have multiple tenants on the same system, and by the way, your data is shared. You need to protect that because all people can access that data now, but you don't want all of them to access data. You want to prevent that. It's a very deep topic. I can keep going on, so go ahead. That's a very good question. Maybe if the benefits and performance characteristics sway the other way. So let's say you do not have any overhead of running virtualized infrastructure. Maybe someday we will, but we got a giant legacy here for 8 years. It's different clusters have different sizes. The biggest ones are roughly 4,200 nodes, 4,200 servers, yeah. But again, the idea is to continue to scale that, push that boundary. There is no real limitation or size limitation, so to say. What happens is that, so for example, even a 2,000 node cluster can be gigantic in terms of demand compared to a 4,000 node cluster. That size really has no bearing. What you want to do is actually manage your namespace effectively and the resources effectively for whatever size. The other issue is having multiple clusters is because we have multiple data centers. We don't want to move data back and forth between data centers. So that's yet another factor why we have multiple clusters. And then we have clusters for different purposes, which also results in number of clusters. As I said, it would have been beautiful if we had one single cluster in one single data center that would give us exact same performance characteristics as we have today with multiple of them. That's not the case today.
What do you see happening with the purple line? Clearly there was an inflection point downwards on yard. Do you see it stabilizing because it's replacing old hardware?
Good question. So when I went to eStaff, I claimed credit because of Jan, that it's going down because our utilization's improving. So we need lesser servers to do the same job as before. But quite honestly, some of it is Moore's law as well. So as we're doing tech refreshes or refreshing our servers with newer hardware, they actually can do more. So some of it is Jan, yes, but some of it is just pure Moore's law. Yeah. Yeah. No. Last year, actually early this year, there were a lot of people asking us to open source that. We looked into it. It's not a core product, so to say. There's like half a resource working on it. It's a gigantic effort to actually open source it, or make it open sourceable. Maybe we will do that. I don't know the answer. Again, the primary rationale for open sourcing something is that we want the benefit back to us as well, like from all of you, from the community. We are not quite seeing that there. Yeah. So there are two efforts there. In terms of the name node scaling to handle a larger cluster. One is around vertical scaling, so you want to be able to have a single name node handle more and more. But again, eventually you will hit the memory limitation for the name node. Our name nodes are 128 gigs of memory. But eventually you will hit that no matter how intelligent of a science you apply. The other idea, which is actually the code exists in 23 or Hadoop 2.0, is what we call as HDFS federation. So the idea there is that you federate the namespace among multiple name nodes. And that basically, the concept basically is about pooling, so to manage it more effectively. There are many kinds of other things that has happened to actually scale that. There is an initiative called Giraffe file system. You should look at that. There are a bunch of other things happening. There are some proprietary techniques that you could apply to scale that. But more or less, they all go with this idea that you save that namespace someplace else. And that has pros and cons in terms of approach. But both of these efforts are underway. Federation actually has been tested to work properly at Yahoo. We just haven't reached a point where we're seeing a need, a dire need to actually deploy that in production. And then, by the way, if you start to federate the namespace, it starts to have implications on all the higher level components. For example, Hive will not work or cease to work. So there's a bunch of work that needs to go in there as well and other components at the same time to make federation work. So that's something we're planning for in 2014 if we get to that. And our belief is that sometime around the middle of that next year, given how the platform is growing, we'll have to do it. But right now we're relying on vertical scaling. Anything else? Okay, thank you very much.